Okay, good morning ladies and gentlemen, and my name is Brice Panugali, and I am going to talk about the application of logarithmic functions. So first off is the Richter scale. The Richter scale is used to represent the magnitude of earthquakes. Since there are such large variations in magnitudes, the scale uses logarithms and is given as m equals log base of 10 over I sub naught. So don't ever forget this formula. In this formula, m is the magnitude of the earthquake and I over I sub naught is the ratio of the earthquake intensity I to that of a zero level earthquake that has intensity I sub naught. I is the intensity of the earthquake shock wave, and I sub naught is the intensity of the smallest recordable earthquake, which is a seismic wave amplitude of 0.001. If you are ever wondering why I read it as I sub naught, because according to my research, it is how we math geniuses read it. So, we are going to solve this, guys. First off is we're going to find where is the intensity. Since we are looking for the magnitude, we are going to need the intensity first. So, as said in the problem, I is 1200 times of I sub naught. So, we're going to write I equals 1200 times I sub naught. And we are going to divide both sides by I sub naught in order to get the I over I sub naught, which is the intensity of the magnitude. So it would be given as like this: I over I sub naught is equals 1200. So we have now the intensity of the magnitude of this earthquake. What we only need is to substitute this 1200 into the formula. So m equals log base of 10 over 1200s. That would give us approximately 3.08. So the magnitude of the earthquake as given by the Richter scale is 3.08. Here is another example. The 1960 earthquake in Chile registered 9.5 on the Richter scale. The 1906 earthquake in San Francisco, California measured 7.8 on the Richter scale. How much larger was the intensity I sub C of the Chile earthquake than the San Francisco earthquake intensity I sub S? Since we have two intensity, so I am going to write I sub C as the intensity of Chile and I sub S as the intensity of San Francisco. Now we are going to substitute everything into the formula. The magnitude 9.5 of Chile is then substituted into the formula. 9.5 is equals to log base of 10 over I sub C over I sub naught. And the other one is 7.8 is equals to log base of 10 over I sub S over I sub naught. And the next step we're going to do is to change this into exponential form. So this would be 10 to the power of 9.5 equals I sub C over I sub naught, and the other one would be 10 to the power of 7.8 is equals to I sub S over I sub naught. And next is, in order to compare the two intensity, we have to divide them, which is written as like this: I sub C over I sub naught over I sub S over I sub naught. Since it is an division of fractions, we are going to multiply them, which would cancel the I sub naught, and this would equate to I sub C over I sub S. Now, since we have the value of I sub C and over I sub S, we just have to substitute them. That should make 10 to the power of 9.5 over 10 to the power of 7.8, which equals to 50. So, the earthquake in Chile is 50 times stronger than the earthquake in San Francisco, California. That would be all. Thank you.
Incoming call. I've put it on screen.
Hello everyone, so I'm gonna give you tutorials about exponential functions. There are two kinds of exponential functions, the exponential growth and exponential decay. So if you're gonna ask me, so exponential functions is any function in which an independent variable is in the form of an exponent. They are the inverse functions of logarithms. So let's start. Exponential decay. So I have an example here. A Honda Accord depreciates at 15% per year. 6 years ago, it was purchased for $21,000. What is it? What is the worth of it now? So, how much is it this year? So, let's find out by using the formula of the exponential decay. So, the formula for the exponential decay is Qt is equals to Q sub O quantity 1 minus R to the power of T. So, in this example, the given was the Q sub O, which is 21,000, and the rate or the percentage by which original amount will decline each time is 15% or 0.15. Then the time is 6 years ago, so 6. So let's try to solve this problem, okay? So Qt is equals to Q sub O quantity of 1 minus R to the power of T. So Qt is equals to Q sub O. Q sub O in our formula, Q sub O is the original amount. So it's gonna be 21,000. Then 1 is constant minus the rate. The rate or the percentage by which the original amount will decline each time. So it is given there that it depreciates at 15% per year. So 0.15. That's exactly the rate or the percentage. So, and then the t, which is the exponent, it's given there that 6 years ago it was purchased for $21,000. So 6 years ago, so it's gonna be 6. The time will be 6. So Qt is equals to 21,000 quantity of 1 minus 0.15 to the power of 6. So 1 minus 0.15 is equals to 0.85. Then next is Qt is equals to 21,000 times 0.85 to the power of 6. So 0.85 to the power of 6, 0.85 to the power of 6 is 0.38. So 21,000 times 0.38, the value of which when you multiply these two is 7,920.1398. So approximately 7920. So every year, as its percentage is depreciates at 15% per year, so the Honda Accord, so the worth of it now is approximately $7,920. That's how you find the exponential decay and how to solve exponential functions in the decay area. So thank you for listening, and thank you for allowing me to introduce you to the world of exponential functions. So thank you, and that's all for my tutorial for today. Okay, goodbye.